And so, hi, and welcome to our first lesson on Chapter 3, which is going to involve graphing systems of equations. And what we use graphing systems of equations for is if we have two lines and we want to find out where those two lines cross, whether they're talking about a real life situation or we're just looking at the general line, we could have an example like this. Let's say we have the line x plus y equals 4, and we have the line 2x plus 3y equals 9. Notice that those are both lines because they both have two variables to the first power, nothing squared, nothing as a fraction, meaning that they're both lines. We can solve these for y, and it's going to make it much easier to graph. So let's make this first equation red and make this second equation blue. So first we'll solve the red equation for y. We have x plus y equals 4. We'll subtract x from each side. We get y equals negative x plus 4. As far as the blue equation, solving that for y is going to be a little more involved. So we have 2x plus 3y equals 9. We'll try to get this y term by itself. So we're going to subtract 2x from both sides. We're going to get 3y equals negative 2x plus 9. Now to get this y by itself, we'll divide both sides by 3. And remember, when we divide two terms by 3, we have to distribute it. So these are going to cross out. We'll get y equals negative 2/3 x plus 3 for our blue equation. Now, before we had learned to plot points to graph these lines, but let's take a look at a different sort of trick once we have these solved for y. Remember the equation y equals mx plus b, where m is your slope and b is your y-intercept. Well, now each of these equations has those two properties associated with it because we put them each in y equals mx plus b form. So for this red equation, we see that b is equal to 4, meaning it crosses the y-axis at a point of 0, 4. Once we put that y-intercept on there, we know that it has a slope of negative 1. So we're going to go down 1 into the right 1. Down 1 into the right 1. I'll put my line on here. Make sure it goes through all 3 points.
Kristen, Doreen, please return to the art room.
So now, let's make that line red again. Now we have the second line, y equals negative 2/3 x plus 3. Notice our y-intercept is 3. So we'll put a y-intercept right here. I'm sorry. Actually right here. At y equals 3. It also has a slope of negative 2/3, so I'm going to go down 2 and over 3. Down 2 and over 3. And I'm going to put a line between those 3 points. Notice they cross at one point. The system of equations crosses at the point right here, which is over 3 and up 1, so it's the point 3, 1. this would be my answer. The solution to this system of equations is going to be 3, 1. Alright, so for our second system of equations, we're going to have the equation 2y plus 3x equals 6. And we're going to have this blue equation 4y plus 6x equals 12. So again, let's solve those for y to get them in slope-intercept form. First, we want to get this y term by itself, so we'll subtract 3x from both sides. We get 2y equals negative 3x plus 6. Let's divide by 2. We're going to get y equals negative 3 halves x plus 3 for our red equation. For our blue equation, again, let's get that y term by itself, so we'll subtract 6x from both sides. We'll end up with 4y equals negative 6x plus 12. So let's divide both sides by 4. So we get y equals negative 6/4 plus 3, x plus 3. And then we can simplify that and we get y equals negative 3 over 2. If we divide both the top and the bottom of the fraction by 2, we get y equals negative 3 halves x plus 3. Notice that is completely identical to the red equation. So they're actually both going to be the same line. So let's graph it. We see our y-intercept is at 1, 2, 3. The slope goes down 3 over 2 because the slope is negative 3 over 2. So we're going to go down 3 over 2. Let's put a line on there. It goes through all 3 of those points. And we have both the red line and the blue line shown on the same line here. This means that they have an infinite number of solutions. So you can write infinite solutions for your answer. One other case you could have is if you have two parallel lines. So let's say we had a green line that's completely parallel to this purple line. In that case, you would have no solutions. So if the lines never cross, you have no solutions. If they cross once, you have one solution. And if they cross everywhere, you have infinite solutions. Let's just summarize that. If our lines intersect, that means we have one solution. And we call that line, the term for that is consistent and independent. That's if the lines intersect and you have one solution. If the lines coincide, in other words, that they're the same line, you're going to have infinite solutions. This symbol means infinity. So infinite solutions. Your lines are consistent with one another because they have a solution. But this time they're dependent on each other because they're the same line. They don't have just one solution. Finally, the third possibility is if your lines are parallel. They never cross, so they have zero solutions, no solutions. This means that they are inconsistent because they don't cross. Again, just math lingo to go along with the three types of possibilities we can have.